So thanks for inviting me to be here. As Tyler said, I'm Ed May. I'm based mostly in New York City, and we've been doing Passive House for about 15 years or so. I was originally much more hands-on in the field. Nowadays, I spend pretty much every day sitting behind a computer. So I thought it would be fun today to talk a little bit about some of the new AI and machine learning tools that we see out and available, and how they might be useful to those of us who, like myself, sit behind a computer all day trying to deliver these passive house projects. So I apologize in advance if you're more in the field. Most of what we're going to be talking about today is going to be more for the desk jockeys amongst you. But hopefully it'll be fun. And the agenda here is to just kind of touch on, I wanted to sort of survey some of the tools, talk a little bit about how they can impact our work as passive housers, show some examples of how they are already being used by our team internally, and then sort of finish up with some lessons learned and maybe some things that we can kind of talk about. So I'll definitely try and leave some time at the end for folks who have any questions or thoughts that they want to interject. Hopefully we can keep it interesting here. Um, I guess one asterisk just for all of this stuff. Nobody can be an expert in this stuff, right? These tools have only been around for a few years, so anybody who pretends that they're an expert in these tools is feeding you a bill of goods. We have a bunch of experience with them. We've tried them. We're still learning how they work and what they're good at and what they're not good at. But we are actively trying to fold these into our process. But by no means am I an expert. And I would again kind of caution against anybody who says they are an expert in these tools. These things have only been around for a few months in some cases. So there's, just take all of that with a grain of salt. So again, the agenda here today, we'll just go briefly. I want to talk about some of the tools that we use for generating text. We'll talk about generating images and generating 3D models, which is of particular interest to those of us in Passive House land. We'll talk a little bit about the capabilities of some of these tools when it comes to analyzing things like images and models. We'll talk some about agentic AI tools, what that term means. And then, as I said, we'll finish up with a little brief discussion of kind of what I think, or maybe some of the things that we think about when we think about like, how are these tools going to really impact Passive House project delivery in the future? All right, so let's jump right in. Generating text. Hopefully, I don't have to kind of describe too much about this. I would assume that most people on this call have experimented with or used some of these text generation AI tools. I'd be curious to know, please add your voice to the chat if you have used these, if you found them useful or you found them not useful. We use these a lot for maybe a few different use cases. Probably first and foremost amongst those is just learning. So I personally have found these tools to be incredibly useful answering questions or learning. So when I'm presented with something that I don't understand or that I don't know about, I've actually found these text generation tools to be really, really useful as learning aids, learning tools. So I would say that's probably use case number one that we find for these text-based tools. The other is actually generating text for use in client-facing products. We do a bunch of, reports and things for clients. And so typically what we're using in that case is these tools as editors. So maybe we'll produce a draft, we'll give the draft to these tools and say, please clean this language up, make it more professional, check it for grammar, check it for spelling, and whatnot, and sort of have it clean up. So clean up the text. So we're sort of working together with these text generation tools to try and help us craft things that we then use as part of our client facing products or deliverables that we might use. So kind of two main use cases for these text generation products or tools. Of course, the thing that you have to keep in mind with all of these tools is that they just make shit up sometimes. So you really do have to be very, very careful when you use these tools. Of course, is the famous how many R's in the word strawberry error that ChatGPT became sort of a meme a couple of years ago when ChatGPT first came out. I think they fixed this specific error, but I think it's illustrative of the fact that sometimes these tools just make things up. And it's a sort of fundamental behavior of these tools is that they basically never say, I don't know. That's like not really a thing that they are ever capable or willing to say. And so they'll always try their best to give you an answer, even if they don't know, even if they actually can't figure it out. So any place that you need really specific answers, any place that you need like really specific results, you're going to want to take all of the text generation with a hefty grain of salt. Now, the tools have gotten much, much better over time in terms of providing breadcrumbs so that you can figure out where it's sourcing a lot of this material from. So, these types of errors, the companies that are making these things are working hard to try and figure out how to overcome or not overcome, because again, you can't really ever overcome this. It's called the hallucination problem. You can't really ever overcome this problem, but at least you can put some guardrails around it and try and provide some traceability to some of these things when it comes to these tools. So again, we don't need to talk too much about that, right? Those tools have been around for a few years now. Those are, I think, probably most folks here have had some experience with those at this point. Those text generation tools. Probably a little bit newer and maybe less integrated into most people's workflows, certainly less integrated into our own at the moment, are the new generation of tools that can be used to generate not just text, but imagery and actual 3D models in some cases. So there's many, many different tools that can be used for this purpose. So some of the really basic ones, like even let's say ChatGPT is a kind of a popular one. That's actually pretty good at image generation. It's slower than many others, especially if you're still on the free plan, but slower is relative. It only takes maybe 5 or 8 seconds, maybe 30 seconds at the most to generate an image of a Sasquatch performing a blower door test in the style of Hanna-Barbera cartoons from the 1980s. That's kind of amazing. So yeah, 30 seconds is slower than some of the others, but it's still a heck of a lot faster than I could draw it by hand, that's for sure. So, this is a really useful tool for producing all sorts of documentation in particular, we use it for a lot of client-facing reports. Just a few months ago, I was doing like a summary memo on air sealing techniques, and I needed an image of somebody, painting on liquid apply air seal, just as like a background image in the report. So these kind of tools are great for that, right? You can just go and generate these kind of images very, very rapidly. So the tools are very, very flexible and they're quite good. They still make things up. They still will do some weird things, like who knows what's happening with the hose in that. But those are to be expected. Those kind of weirdnesses. All in all, I think that's a pretty good result. One thing though and this comes by way of my 14-year-old nephew, he said to me, no, 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 you're doing it all wrong. You don't just tell the AI tool what image you want it to generate. First, you tell the AI tool to rewrite your image prompt more specifically, more descriptively, in a way that's going to get you a better result. Then you give that generated prompt back to the same AI. So you do this kind of cyclical work. And this is actually something we'll come back to later on when we start talking about agentic workflows. Using these tools to generate the input that the tools need to do a good job is actually a sort of a basic workflow that does in fact work quite well. So you can take that sort of basic prompt of a Sasquatch performing a blower door test on a passive house, and you can tell the AI tool to rewrite that image prompt and do it better so that we get a nicer image out the other end. It will write a much more thorough and detailed prompt, feed it to itself, and then kick out an image like we see here. So that iterative workflow is actually core to many of these AI tools, and is what we're finding as we're experimenting with these. So we definitely use these tools. There are some kind of strategies for them. One way that we've been using them lately is to take basic line drawings from our 3D models and bring them to life a little bit more. I know Greg Fisher's on. You'll recognize this one, Greg. I was sort of experimenting with some of our documentation and our reports, and our 3D models can kick out drawings like on the left there pretty easily, right? What you can do is with some of these tools, in particular, the tool here we're showing is a tool called Adobe Firefly. You can feed that original image in, and you can say, redo this image, remake this image in a different style for me. So for instance, take this line drawing and remake it as if it was an architectural 3D model made out of basswood. There's not any particular reason. It doesn't help us engineer anything, but maybe it makes for a more compelling client-facing output there. Now, there's some weirdness. Notice what's happening with the chimneys on the image on the right there. But by and large, I actually think that's a pretty good replication. I mean, it would take some work to get it to actual client-facing quality, but you could make a much more compelling image very, very quickly there. The reason I highlight this Adobe Firefly is that one of the useful features that it has is the ability to upload a reference image, and you can tell it, maintain this composition. So I don't want you to change the composition. I don't want you to change the shape, the alignment, the perspective, but I want you to restyle it in a certain way. It's got a whole set of tools that you can use to sort of lock in certain aspects of the image and then allow it to generate certain other aspects of the image. So you can do this kind of image generation with a basis. And that's actually super useful for architectural workflows where it's important that we don't have 5 extra chimneys as in the image on the right there, right? So we want to be able to control certain aspects, but then allow it to generate other aspects. So I thought this was an interesting use case. We haven't quite folded this into our own workflows just yet, but it's something we're toying with the goal of making better communication documents, with the goal of making more compelling and interesting client-facing documents in order to communicate better. That's a big part of what we do as passive housers. When it comes to the actual passive house modeling workflows, an interesting workflow that I saw piloted recently using Google's Gemini tool and their new image and model generation was to take imagery, again, imagery of a building, and in the case here, just taken from Google, those are just Google Maps and Google Street View images of a building. And again, you can feed these images into these tools and say, oh, these are the reference. And I want you to build something based on these references. Don't just make it up whole cloth. I want you to take elements and I want you to take this as the base and build on top of it. So for instance, we can feed in a few interesting images here and we can say, I want you to make me an image, as we say in the prompt here, preserve all the building's massing, proportions, fenestration, render it with physically based realistic lighting and shadows, and show me a top-down view of this building. I want you to basically like recreate this building and show me a top-down or an isometric view of that building. And it's not perfect, but it only takes a few seconds, and we're able to get a basically 3D model-esque output from one of these tools. So that's interesting. All right, so I can feed in some imagery, just some basic photographs, and I can have it produce images as if they were from a 3D model. Well, what can I do then with that? Well, we can then take that output and we can use it to generate, for instance here, an elevation in the style of an architectural line work drawing. So maybe we want to pull that in to some other representation tool. We want to use it for diagramming or something like that. Right? We can very, very quickly. I mean, these literally takes 5 or 6 seconds to generate. We could very, very quickly generate this type of imagery if we want to use this for something else within our process. We can also, though, take the output from those image generation tools and feed them into other tools. So there are other tools, like the one that we're showing here, which is a tool that takes images and actually generates 3D models from those images. So it takes pictures and it turns them into actual 3D geometry, which we can download and open up in our 3D modeling application. Now, these tools are not in any way able to produce a clean, watertight, passive house-esque 3D model right now. But the important thing to remember about all of these tools is that this is the worst that these tools will ever be. These tools will only gain capabilities, get faster, get better, get more accurate over the next few years. So currently, we can take a few Street View images from Google, turn it into an image on the left, feed it into another tool, generate a 3D model, and download it into Rhino within the span of a few minutes. Again, it's not perfectly clean. It's heavily faceted. It wouldn't be, something that you could feed directly into PHP or Wolfie Passive, but it's getting there. And as a workflow, I think that offers us a lot of interesting opportunities. At the very least, it offers us a much easier way to bring in things like context, which does not have to be as clean and as perfect and as accurate as the actual building model. And then certainly as reference as we're building up, if we're working on existing buildings or existing conditions. So some interesting workflows there that we're toying with, that we're using in our process. A couple of really cool tools that we can use to do that kind of generation, generating text, generating images, generating 3D models. But of course, in Passive House land, we're also super interested in the question of analysis. So we have a model, but what can I do with it? Can I analyze that model? Can I analyze and tease out the data from that model in order to do something, in order to execute some calculation, in order to learn something about the building? Now, this happens not just with buildings, but of course with more banal data that you might have about your project. One workflow or one task that we find super obnoxious and a complete waste of everyone's time is the task where we get a giant table of data and we have to pull the data out and turn it back into real data in a tool like Excel or something like that we can then use to actually build a model. The architectural workflow where we make PDFs of data and then hand it around as if that's an effective way to communicate data is one of the dumbest ideas I've ever heard, and is fully preposterous. But it's very common, right? It's very common that we get a giant table like this and somebody says, pull out all of the outdoor air flow rates and assign them to the right rooms within your model. You say, okay, fine. It's a PDF, so I can go in and I can select it and I can copy it and I can pull it out into a table. Except that about 50 or maybe 75% of the time, when you zoom in on the table, you realize that it's actually not even text. It's an image. It's a picture of data. Somebody had data and they turned it into a picture of data in order to give it to you as if they were communicating actual data to you. But they weren't. They were communicating a picture of the data. Okay, fine. There are nice tools nowadays. In particular, there are some that are built right into tools like Microsoft Excel that allow us to take pictures of data and turn it back into real data that can be used to actually build models, perform analysis, generate useful results. Tools like Excel can extract that data using certain character recognition algorithms and pull that data back out. So yes, you've been given a picture of data as if someone was actually communicating something to you, and you need to turn it back into real data so that you can use it in a real passive house model. There's good tools that allow you to do that nowadays. And as I said, probably the best one that we like is built right into Microsoft Excel nowadays. And so you can just tap right into that. There are other methods to do it, but that's a nice, easy one. Now, once you have the data and you've built up your data model, once you know what you're building, once you've got your kind of picture of your building, one question that often comes up is, okay, these physics-based modeling tools, Energy Plus and whatnot, these are pretty slow, especially with really big buildings. Is it possible that we could move to a scenario where we're using statistical modeling methods instead of physical modeling methods in order to perform analyses and learn things about these buildings? One interesting example, if you're not familiar with this tool, Space.io, I'm not sure how to pronounce it. It's a web-based modeling tool that allows you to do all sorts of really interesting stuff, AI-generated buildings and whatnot. What you're looking at here is daylight assessment, daylighting factor, basically calculated in real time, live on the internet for the massing of these buildings. And as they change, the daylight factor gets updated. But the important thing about this calculation is that it's not doing typical ray trace physics-based daylighting calculation. It's performing statistical daylight factor prediction using machine learning and AI tools. And it's doing it very, very rapidly. Now you can say, oh, but that's not going to be as accurate and you're not going to get the right results. And okay, yeah, fine. Maybe for a construction drawing level model, this would not be appropriate. But if you're in the SD phases, if you're in the early massing phases, this might be perfectly appropriate level of detail for your project, and it might give you exactly the information that you need at a speed that simply can't be matched by many of these other physics-based modeling tools. So that's interesting. So could we do something similar with our passive house models? I mean, could we do a kind of energy analysis with the same rapidity and speed and sort of tactility of feedback? Could we do something similar for passive house and move away from physics-based models towards statistical models, at least for certain phases of our workflow, especially in the earlier phases, let's say? The answer, of course, is no, not yet. Passive house tools are in no way built to interface with or work with these types of tools. The passive house modeling tools are very manual in their processes. They have basically no ability to automate or improve workflows built in. And so there's really no way that we can do anything like this using the existing modeling tools, but that doesn't mean that we're not working on it. So in particular, in this world, one of the vocabulary terms that you might hear thrown around is Model Context Protocol, MCP. If you haven't heard that term before, that's a term in the sort of AI world. A few months ago, it's only maybe 4 or 6 months old, one of these AI companies, Anthropic, they developed a standard for what they call model context protocols, MCPs. MCPs are basically adapters or plugs that you build for your application that allows these AI tools to talk to them, to work with them, to learn from them, to speak to them. Think about an adapter. I'm in Santiago. I have a lot of American plugs. I need an adapter so my American plug can plug into the Chilean power outlet. These AI tools are very similar. They need a standardized method of talking to your application. So you build PHPP or Woofy Passive or Energy Plus. We need to develop some sort of model context protocol or some sort of adapter to allow these tools to talk to our models more effectively. Now, this doesn't exist, right? This is not a thing right now. But in our firm, we are, as Tyler indicated, the maintainers of the Honeybee PH, and Passive House Exchange software libraries. And while these are not MCPs, these are not model context protocols, the Passive House Exchange library is the first step towards what we hope to be an eventual generation of a effective MCP for passive house models, so that you could say, hey, ChatGPT, here's a Woofy model, change all the windows to use a different glass. That might be something that you would just want to do rather than clicking that you might want to tell an AI tool to do for you. You cannot do that right now, but we are hopeful that someday you will. We're actively trying to build out some of those tools right now to allow us to do that type of work in the future. So maybe we'll get there someday, but at the moment, no. Now that brings us to agentic workflows, and that's a weird word. And yes, they really did name them agents, as if nobody's ever seen a movie before. What are agents? What does that term mean when it comes to AI tools? AI agents are autonomous processes, little bundles of ability that you can authorize to do real things on your computer. So not like ChatGPT that just gives you some text, but a tool that can actually go into your computer and make changes, can change data, can add files, can delete files, can do other work without your direct supervision or direction. It's a little ambiguous. What does that mean exactly? Here's an example. So this is, if you're not familiar with something like this is a coding tool called VS Code. It's just a coding tool. It allows you to write software code, as you see in the middle. On the left-hand side there, you see a list of files that are part of this project. And on the right, there's this agent tool, which is built in to this application. So this is an application that you install on your computer and you use it to write computer code. Well, nowadays we can use these agentic tools to go in and say something like, update the user. So we have this user object, update that user class so that it can be instantiated from JSON data. And then please create a new JSON file with some test data, and then update the tests and run all the tests to make sure that the program is not broken and still working. You can see on the right-hand side there that the agent is now getting to work. So the agent starts to tell you all the things that it's going to do to your computer. You can see a little to-do list up there on the top. It's going to go through these steps one at a time. So you can see here, it says, okay, I'm going to start by going in, and the green there is new code that this agent just wrote. So this process just added a bunch of text to a file on my computer. Right? I didn't type that, the computer typed that for itself. On the left, you can see it created a whole new file with some random test data that it's going to use to test the functionality of these new features, these new functions that it just added. So it added an entire new file. You can check its to-do list there and see that the to-do is about halfway done. Now it's going to update the test file and then run the automated tests to make sure that it didn't break the application. So you can see here that it wants to run the tests, and it says, oh, will you allow me to take this action on your computer? Yes or no. And you can approve that action on your computer. And now it's going to do all the automated testing there. It's going to test it a few different ways so that it's sure that everything is running properly and that it hasn't broken anything as it's gone in and monkeyed around with the code in this application there. And you see there's all sorts of things happening. There's like stuff flying around. But the important part here to understand is that the computer is doing all of this in a largely unsupervised way. It's making decisions, it's set up that to-do list, it moves through the to-do list one item at a time, and then at the very end, it says, okay, I did all this stuff. Do you want to keep it or do you want to discard it? So these agentic processes are useful when you want to build real things, when you want to do real things, when you're not just looking to have a conversation and kind of chat about it, but you actually want to execute something. That's where these AI agents come into play. Now, one real world example, and then we'll leave a bunch of time for questions here. If you're familiar, in Google, you can type in something like inches squared to millimeter squared, and it has this handy conversion tool. So this is just built into Google. And that's super useful, right? It's fast. You can just type in what you want, and it will do the conversion for you, which is super nice. So I like that. That's good. That's good UX, in my opinion. But in passive house land, we're often using units like kBTU per square foot, and we want to convert it to kilowatt hours per square meter. Google doesn't know what to do with any of that. So if you try and do that in Google, you're going to basically get nothing. You're going to get kicked off to some other sort of conversion tool. So I was annoyed by this last week, or a couple weeks ago. And so I decided to try as an experiment to use some of these agentic tools to build myself a converter application. And I wanted it to work just the way that Google did. So I want to be able to put in what I'm thinking, 1 meter as feet, or 1 kBTU per square foot as kilowatt hours per square meter. And so this is just a super, super dumb little web app. It's just got 2 panels and it's got some logic in the background. I could have built this by hand, but I wouldn't have built this by hand because while this problem is annoying, it's not annoying enough to spend 3 days scripting and writing an application like this. So I just never did it. But when you can hand this off to one of these agentic tools to produce in an afternoon, well, now all sorts of new things are possible. Now, when we code in this manner, when we produce things in this manner, go back to that original point I made about ChatGPT, we don't actually write out all the instructions ourselves. What we write is on the left there. A very simple React application which can convert user inputs from 1 unit, meters, into another unit, feet. That's it. That's all I wrote. And then we set these tools to work. And we say, the first thing I want you to do before you write any code, don't even think about writing code. I want you to create what's called a project requirements document. I want you to outline all of the elements and aspects of this project that we're about to undertake. Then based on that, I want you to produce a detailed step-by-step task list. And before you ever do anything, I'm going to go review those and make sure that I'm happy with them. So the first thing we have it do is produce what's called a project requirements document. This, you can see here, it generated all this. I did not write this. The tool generated this based on my like 5 lines of input there. You can see here it's got an introduction, an overview, goals, speed and efficiency. It's got user stories about like who's going to use it and how are they going to use it? How quick does it have to be? How fast does it have to be? This is like high level. This is not code. This is just a description of what the heck it is you want me to do. Based on this, then, we have it generate a detailed step-by-step task list. The first thing you're going to do is you're going to set up the project. You're going to set up the Git repository. You're going to set up the linting, and then you're going to build the conversion engine and blah, 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 right? There's a detailed task list. This is still not code, right? There's no computer code here. This is all just descriptive text. Based on this, then, the agents can then get to work. So this is the process that we use, this kind of iterative context building process is what we have found to be the most effective way to work with these AI tools in order to build a real thing, right? You don't just say, build me an app. You have to build up this body of context. Then you have to go in and edit it, revise it, refine it to be exactly what you want. And then you can set these tools to work. So this little stupid app here, it's hosted for free on GitHub Pages. Yeah, so free, it's totally free. I developed it using this AI tool in about a day. I futzed with the UI for a little bit to kind of get things to line up right so that it like looked good on mobile and blah blah blah. But it was basically a day to get the whole thing done. And we were kind of experimenting with some of these different tools here. And if you're curious, you know, the way that these tools are billed nowadays, it goes by what they call the token. Basically the word. So like each word is, I don't know, 0.0003 cents or something like that. You can see here in the graph, this is a graph of my usage of these tools, basically futzing around with them on the weekends, is what you're seeing here. And that one day cost me about $1.75. So to develop that app, which I now use on my computer every couple days, we use it quite often. It's fast. It works the way my brain works. It cost me about $1.75 to develop that. And then now it lives on the web and I can install it as a progressive web app on my computer. That's like a whole new world where we can sort of build these quick, sloppy, stupid apps that you never, ever would have made a few years ago. You could have, but you wouldn't have. Now, all of a sudden, these things are possible. Now, if you're not a coder, if you don't like to code, if you don't know how to code, you don't want to code, there are lots of interesting tools that are available nowadays, things like Lovable and Replit, GitHub Spark, that you don't need to code at all, that actually take that whole process that I just described and abstract it into a basically an app that you use to build these kind of custom, not throwaway, but like small apps that you use to do something useful. So when you have a part of your workflow that's frustrating, obnoxious, slow, we now have some really interesting tools at our disposal that we can use to speed up that process and really improve our workflows. So I would recommend that you take a look at some of these and see if they might work for the types of things you're doing. Okay, so briefly, future. Who the hell knows? What do I know about the future of AI? I couldn't possibly tell you what the future is going to hold for AI. This stuff is moving very, very fast, and there's no possible way that I could tell you what's going to happen over the next year. But we can make we can say a few things about how to think about these tools moving forward. So first of all, it is imperative that when you start folding these tools in, that you are in control of these tools. These tools are incredibly powerful, and like any other powerful tool, can get out of control. And when that happens, all sorts of nasty things can happen. You cannot just ignore these tools and set them to work. These tools do not work for you, they work with you. So it's imperative that you are in control and managing all these tools. You don't use the tools to do things you don't know how to do. You use the tools to speed up things that you don't want to do. So keep that in mind as you start thinking about how to integrate some of these tools into your projects. We should also, of course, approach all of this with a lot of skepticism. There was a report that came out from MIT just a few weeks ago that found that about 95% of enterprise organizations that have started to fold these AI tools into their workflows are seeing basically zero return on that investment, zero improvement in their business processes. 95%. So only 5% of enterprise customers who are spending billions of dollars integrating these tools are actually getting something for that investment. The report suggests that the fault is not so much with the tools themselves, but with how people are using the tools. How are these tools built in to overall business processes? But the important thing here to understand is that these tools are not just a sort of fix it button or an easy button, right? You have to really think hard about how and where and when you're going to integrate these very powerful tools into your existing workflows in order to speed things up, in order to do a better job at your job. And it's very easy to just throw these tools in and actually not see any benefit at all. The report here also outlined a few what they called myths about AI, that sometime in the next few years, we're all going to be out of a job. Nonsense based on what we've seen so far. Again, who knows the future? Maybe some lab from China comes out with like the most amazing tool next week, and this could all be wrong. But based on what we've seen so far, the idea that we're all going to be out of work in the next few years seems unlikely, let's just say. That the AI tools are transforming business. As I said, only about 5% of enterprises surveyed have actually shown some significant improvement there. And a couple of other interesting sort of myths here when it comes to AI tool. One of the other things to say about all this, probably should have said at the beginning, that there's a lot of bullshit. I mean, it's 2025. Reading things on the internet, mostly what you're going to find is garbage. People are full of nonsense. So that, again, you have to approach all this with a lot of skepticism and sort of asterisks next to almost everything, because there's a lot of nonsense being slung right now. Just the other thing to say is, when we think about these questions, it's important to remember that we're not talking about AI, in quotes, just the sort of abstract technology. What we actually have is a very, very specific version of AI, which is developed by these enormous planet scale, privately owned corporations focused exclusively on making as much money as they possibly can. That's different than AI, in quotes. This is the version of AI that we are getting, that we have at our disposal. And so again, we have to approach all of this with a lot of skepticism and a lot of care, because, these folks they're not here for your best interests. Let's just say that. But that doesn't mean that we can't use these tools and we can't integrate them in and make use of them. These are very powerful tools. We do have to understand that they come from a very specific place, a very specific context. To be aware of that as we start to engage with them. And then lastly, and then we'll have a few minutes for questions. I thought this was a great quote. This is the kind of famous meme from, I don't know, a year ago now. I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and my writing so that I can go do the laundry and the dishes. And I think that's what we should strive for with integrating these tools into our passive house processes. Don't lose the fun part of passive house design, lose the stupid part. Do not spend hours transcribing data from one spreadsheet to another. Instead, use these tools to speed up the process so that you can engage with clients and really help them deliver better, higher performing buildings. So with that, we'll come to the end. Go build yourself some cool things using these tools. And I would, of course, be happy to hear any thoughts or questions that anybody might have regarding anything that we've talked about here today. Again, I'm not an expert, so I'm not promising that I can answer your questions, but I'd love to hear your thoughts. And if I can answer, I'd be more than happy to.